Hi guys. So we have finished up with Pythagorean theorem. We'll get back to that in another section or two when we have a little quiz on Pythagorean theorem. But we're going to move on to something called simplifying radicals. Now, this will be familiar to you because we've seen this in Pythagorean theorem. When we have something that looks like this, square root of 25. We've seen that in Pythagorean theorem. Now, what we've done before, if we see the square root of 25, we've just plugged that into our calculator to give us an answer. So when we see the square root, remember, this is called our radical symbol. The number underneath is called your radicand. I'm just letting you know what that number is called. I'm never going to ask you to tell me what it's called. I just want you to know. So the square root of 25, if we do the square root of 25, now some of us know this off the top of our head, which is great. Others of us don't and use our calculator. So the square root, all right, remember the square root button, of 25 equals a nice number. It equals 5. Well, the square root really means what number times itself would give me 25? Well, doesn't 5 times 5 give me 25? And another way that we write 5 times 5 is 5 squared. All right, so what we're going to do is we're going to practice putting these into our calculator. We're pretty good experts at that since Pythagorean theorem. It says find the square root and round to the nearest tenth. That means 1 decimal place. So we want to do the square root of 52, which is 7.21, so it's just 7.2. So this is nice and easy, just plugging them in our calculators. Square root of 75 is 8.66. So if it's 8.66, that really should round to 8.7. Okay, so nice and easy, right? It said use your calculator. Not everything's going to be that easy, all right? What we want to do is simplify our radical, all right? Just like if I gave you the fraction 4/8 and I said simplify it, you would want to reduce that to 1/2. 1/2 is really the same thing as 0.5 in your calculator, but I just wanted to simplify it. So now we're going to take a look at a way where we can use numbers to help us simplify. So what we're going to do here is we're going to make a perfect square list. So you've probably heard of perfect squares before, and that's just something like 5 squared, 5 times 5, maybe 8 times 8. All right, so 1 times 1 is 1, and that will never really help us out when we're trying to simplify radicals. So I'm going to leave that off the list. But what I do want to know is what is 2 squared? So 2 squared is 2 times 2. We should know that that's 4. Next number I want to do is 3 squared. So you could check it out on your calculator. 3 squared, 3 times 3 is 9. 4 squared. So what's 4 times 4? 16. 5 squared. 5 times 5 is 25. Remember, if you don't know these off the top of your head, use your calculator. 6 squared. 6 times 6 is 36. 7 squared. 7 times 7 is 49. 8 squared is 64. 9 squared, 9 times 9 is 81. 10 squared is 100. 10 times 10 is 100. 11 squared is 121, so 11 times 11. And then we'll stop here at 12. 12 squared is 144. 12 times 12 is 144. So here's what I want you to do. Take a second, pause the video, and maybe grab, like, if you have a colored pencil, a highlighter, or like a red pen, a blue pen. And what I'm going to do is I have a yellow colored pencil here. I'm going to shade in this second column. All right, so do something with your pencil, circle this second column. This is the column that is going to help us simplify the square roots. Only this column. So that's why we want to make this one stand out. In fact, what I'm really going to do here is I'm going to kind of like scribble these numbers out. All right, these numbers help me get the perfect squares. I don't want you using this column to help you do any of the simplifying. If you do, you're gonna end up having the wrong answer. So you wanna look at this last column, all right? So make sure that stands out to you. All right, so let me show you how we simplify these radicals, all right? So I wanna have this list, and I always, you know, on a test or a quiz, you can sit and write this list. That's what I would do. I would sit and I'd say, oh, what's 2 times 2? What's 3 times 3? What's 4 times 4? And I would write this list so that I could look at it while I'm trying to simplify. So when we have 12 squared, notice what the directions say. It says no calculator. It says simplify the radical expression. So we do not want a decimal answer. If you give me a decimal answer, it will be wrong. So we will have no decimals in this section. So here's what we want to do. The square root of 12. I want to look at this list and I want to find a number that goes into 12. Well, the first answer people tell me, ooh, 6 times 2 is 12. Well, that's true, but look at this list. Is there a 6 or a 2 on this list? Nope. So I don't want a 6 and a 2. I want to find a number on this list that divides into 12 evenly. So here's how you do it. You just check it out. Start at the top of the list, 12. 12 divided by 4. Oh, 4 and 3 work, right? 12 divided by 9. Is that going to work out? Nope. And if I get to 16, 16 is bigger than 12, so that will never work. So I know 4 and 3 are my two numbers that work. 4 goes into 12 3 times. So here's how we write this. If the number is on my list first, that's the number I write first. I write the square root of 4 times the square root of 3. All right, 4 times 3 gives me 12. So here's what I say to myself. What is the square root of 4? What times what gives me 4? 2. Square root of 4 is 2. So I'm simplifying that. It's just a regular old number 2. The square root goes away. But the square root of 3, guess what? There is no square root of 3 that's not a decimal. So I can't simplify that side. I could only simplify the first side. So we bring down the square root of 3. Just bring it down. And guess what? This is your answer. Square root of 12 simplified is 2 root 3. Let's take a look at B. So I want to find a number on this list that goes into 45. However, I want to find the biggest number that goes into whenever I'm simplifying. Not just the first number, I want to find the biggest numbers. So it's just a guess and check. 45 divided by 4, start at the top of your list. Oh, I got 11.25, that didn't work. Let's see, 45 divided by 9. Oh, 9 and 5 work. I'm going to kind of jot that off to the side, 9 and 5. Let's try another one. 45 divided by 16, does that work? Nope. 45 divided by 25. That doesn't work either. 45 divided by 36. Nope. Guess what? It looks like it's 9 and 5. All right? But you want to test a couple more out. Sometimes there's a bigger number that goes into it. So 45 is really the square root of 9 times the square root of 5. I always write this number first, the one that's on my list. The square root of 9 is really 3. The square root of 9 is 3. So the square root of 9 becomes a regular 3. I bring down that root 5. Square root of 5 does not simplify, and you have your answer. Let's take a look at the next two. Square root of 128. Sometimes when it's an even number and a bigger number, there's going to be a couple of numbers on this list that work. Not all the time, but you want to check them out. So let's take a look at 128. 128 divided by, 128 divided by 4. Oh, 4 and 32 work, so I'm going to jot that down. 4 and 32. Let's take a look if there's more. 128 divided by 9. Nope, doesn't work. So the next number to check is 16. 128 divided by 16. Ooh, 16 and 8 work. 16 and 8. So guess what? I'm going to get rid of that set. There's a bigger number that goes into it, 16. But I'm going to try a couple more. 128 divided by 25. Nope. 128 divided by 36. Nope. Let's try a couple more. 128 divided by 49. No. So let's try 64. That's our last one we're going to try. Ooh. 128 divided by 64. Oh, that works too. So 64 and 2 work. So I'm going to cross these out because there was a bigger one that worked. So now I found my set that works. Square root of 64 and square root of 2. What is the square root of 64? What times what gives me 64? Turns out that it's 8. So the square root of 64 becomes an 8, and I bring down my root 2. Last one, square root of 48. So 48 divided by 4, start at the top. Oh, 4 and 12 work. I have a feeling there's going to be something else that goes into 48. 48 divided by 9. Nope. 48 divided by 16. Oh, 16 and 3. That's it. I can stop there. Get rid of the 4 and 12. So let's write the square root of 16 times the square root of 3. The first one is the one that can simplify. What times what gives me 16? Oh, 4 times 4. So 4 all by itself. Bring down the root 3. And that's it. So we're going to stop there. Tomorrow will be part 2 of simplifying radicals.